Now, let's log out of this user. And we'll instead log in as the demo user. The password is the same as before. And then we were going to open up vid. Due to some minor bugs, you may need to do this a couple times for the vid user interface to show up. So we can browse the service model that exists. You can see these are the 3 that have been deployed before with our robot script. Now the one that we want to deploy is firewall closed loop. So let's go ahead and do that. So we've deployed an instance, a service instance of the firewall closed loop. And one thing we want to know here is on the upper right hand corner of the screen here is you see the service instance ID of this instance that we just deployed. We want to make a note of that because we will be needing this particular service instance ID later when we run some of the robot scripts to help us initialize some of the intermediate steps that we will go through. So now that we have this instance created, we want to add some VNFs. The VNFs that we have available to choose, unfortunately, are named with these UUID figures. Offhand, it's hard to tell which one of these corresponds to the firewall and sync. The other one corresponds to a packet generator. So this is where we need to open up the Caesar file that we downloaded earlier. And we want to take a look over here. And then if you want to look in the definitions directory over here, you can roughly read the resource names and how they correspond to whether it's a firewall or it's a packet generator. So let's do the packet generator. So from here we can see that the packet generator corresponds to 086C. So let's do that. 086C is the packet generator. I want to create a VNF for that. I will call the VNF vPKG1. And then here, back in the Caesar file, you can see, just to confirm, the firewall and sync correspond to the resource ID 7B99. So let's add that VNF as well, the 7B99. And I will call this the virtual firewall sync. So that has been successfully created. Now, what we need to do next is to add the VF modules to each of these VNFs that are created. However, before doing that, we need to preload SDNC with some data. So thankfully, the demo script can help us do that. So what I want to do is to preload the SDNC data for the firewall sync first. and this is the command. And actually, let me just show the help here. So we're trying to do demo preload, and we need the VNF name, the module name, and then what type it is. So this is the command that we need. We will preload the firewall sync VNF that I just created, and then the module name. This is the module, the VF module name that I intend to use later. So I would define it upfront right now, and then I specify that the type of this module corresponds to this. So, and then we will remember to use this as the module name that we'll be adding later. Great, that has passed successfully. And then likewise, we will do the same SDNC preload for the packet generator. Okay. Now that that has completed, we can go back to the vid user interface and let's add the VF modules. So let's add the firewall sync module first. And we specify that yes, we have already preloaded the data in SDNC. So what this is doing is that it will actually be instructing OpenStack to be spinning up the actual virtual machines that corresponds to the firewall and sync. And we will check on that a little bit later. In the meantime, let us actually proceed with doing the same module addition, VNF module addition for the packet generator once this completes. So this is completed. Now we will also add the VF module for the packet generator. Remember to use the name that we used in the SDNC preload. Specify that the preload was done. Then we again confirm. So now these virtual machines should be spinning up in OpenStack. So now let's come back and check on the list of OpenStack VMs in our OpenStack stack or instances. And we scroll up a little bit, you see that now there are 3 new VMs that have been created. This one corresponds to a packet generator, this one corresponds to the sync, and this one corresponds to the firewall. So that's great. So these new VMs might take a little bit of time to fully initialize. So while they're doing that, we will proceed with doing some other setup But one thing we do want to take note of are these external IP addresses that have been created for the packet generator, the sink, and the firewall, and we will be using this information later. But in the meantime, what we want to do is to run HeatBridge. HeatBridge is a set of utilities that help us load data about these new VNFs into ANAI for the purposes of this demo. So the command that we're interested in is demo.sh HeatBridge, and we want to pass it the stack name, the service instance ID, and the service. For the stack name, those actually correspond to the VNF module names that we have just entered previously. But we can take a look at the list of stacks that we have in this environment right now, and you can see that the two stacks that have just been created are called Firewall Sync Module 1 and vPackage Module 1 respectively. And then the second parameter is the service instance ID, and this service instance ID is the ID that we got from originally from here. That was a service instance ID when we deployed the service instance. So, and then the service name. So let's go ahead and do that. And then the service ID. And then for the firewall sync service, the service is called vFWCL. Again, what HeatBridge is doing is querying the information about this stack and then loading it into ANAI so that onap is able to recognize and use it for its controls. Let's do the same for the package generator. Great, that has now completed successfully. So now what we want to do is we want to go take a look at the packet generator. So I'm coming back up to look at our server list and finding the IP address for our packet generator. The packet generator VM itself contains a little chart tool at port 667 that will show us the packets that, sorry, not the packet generator, the sink. This is the sink VM that it has a graph that shows the packets that it's retrieving or receiving from the packet generator. So let's turn on the automatic reload, and we can see this is the chart or the graphics of what the packet generator is currently sending to the sink. So we can actually, what we want to do is let this run for a little bit, and what the packet generator is supposed to be doing right now is alternating between high throughput for a period of time and then low throughput for a period of time. So if we're looking at, in particular, this chart for the last 60 minutes, what we should see is basically something that looks a little bit like a square wave. Basically a period of time where there's high throughput and a period of time of low throughput, and it'll alternate between those two. So we will let this run for a little bit.